Dear students, welcome to lecture number 9. In this lecture, we will conclude our graphics or rendering pipeline. So, in order to conclude this topic, we will discuss here the two important stages of rendering pipeline: primitive processing and fragment processing. So, let's start. So dear students, first of all we will discuss point processing, which is actually the rasterization process. Then fragment processing in detail, which is actually the finalizing of rasterization process. Along with attribute processing, different tests to be performed on fragment processing, and to end this with the concept of blending and merging. Primitive processing is implemented with the help of rasterization. Rasterize means it is the process of converting a vector image, a mathematically defined image of points and curves, to a raster image, which is a picture composed of discrete pixels. Hence, for short, the rasterization process is commonly used in real-time 3D graphics processing to convert images quickly for display on computer monitor, which is in 2D format. So to adopt rasterization technique, we required various inputs, which can be vertices with attributes and connectivity information, and also various attributes having color, depth, and texture coordinates. These all inputs results in the form of fragments as output. These fragments represents pixel position, interpolated color, its depth and texture coordinates on a 2D graphical grid for screen image. The whole process is demonstrated in the figure below. If you will observe the figure on the slide at the left side, 3 vertices, 3 points that is shown in black full circles are connected together to form a triangle. This is an input which has to be rasterized with the help of rasterization process on a 2-dimensional grid, which results in the form of fragment. This you can see on the slide at the right side of the figure, where 2-dimensional grid is used in background to represent a triangle. The shaded blocks are actually the fragment which are connected in order to form a triangle. However, the shape is not representing appropriately. Therefore, in order to finalize the rasterization process, we need to perform fragment processing, which help to represent the shape appropriately as a final resultant image. Here you can see the complete illustration of rasterization process, which is demonstrated with the help of figure. Starting from left to right, at the leftmost we have vertices with connectivity, which is input in the rasterization process. Then we receive fragments, that is pixel coordinates as shown in the figure in the middle. And finally, the fragment is mapped to the 2D grid in order to obtain final image in pixel form. Hence, through the whole process, it is concluded that fragment processing is important to finalize the rasterization process. In fragment processing, the fragment attributes are processed and various tests are performed on fragments to finalize the rasterization process. These tests will be discussed in the next part of this lecture. However, these tests process the fragment attributes, also discard the unnecessary fragments in order to pass the test, and finally update the frame buffer in the end. To execute this process as a whole, following inputs are required. Number 1, fragment attributes. Number 2, texture. Number 3, frame buffer. data that is available for each pixel. Position, that is its depth buffer, color buffer, stencil buffer, and accumulation buffer. All these buffers have been discussed briefly in my previous lectures. In this slide, students, you can observe the complete illustration of fragment processing. The points or vertices of a triangle rasterize or connected to start the rasterization process. Then fragments with attributes have been computed, that is their interpolated color, depth, texture coordinates, etc. in order to update the frame buffer. This process is iteratively done until we achieve our final image on a 2D screen. As far as the attribute processing is concerned, 4 factors are important. Number 1, texture lookup, which is use texture coordinates to look up a pixel of a texture image. Number 2 is texturing, combination of color and texel. These both concepts have been discussed in detail in our lecture on texture. Number 3, fog, adaptation of color based on fog color and depth value. And number 4 is very important, anti-aliasing, which is an adoption of alpha, value and color, where color has 3 components, red, green and blue. Hence color is represented as a 4D vector, that is red, green, blue and a new color which is alpha. Dear students, the concept of anti-aliasing will be discussed in more detail in our coming series of lectures.